Hello there, welcome to the October 2020 applied paper. Here we're looking at question 3, the third mechanics question in this paper. I think it's question 8 overall. At time t seconds, where t is greater than 0, a particle p moves so that its acceleration a meters per second squared is given by a equals 1 minus 4t I plus 3 minus t squared j. At the instant when t equals 0, the velocity of p is 36 I meters per second. Question I of part A is find the velocity of p when t equals 4. Okay, so what we're going to be using here is our knowledge that if we integrate acceleration, we get velocity. So v is going to equal the integral of 1 minus 4t on the I component, add 3 minus t squared on the j component with respect to t. So let's integrate. So it's going to become t minus 2t squared. We'll do the plus c right at the end. Plus 3t minus a third t cubed. And then it's going to be plus c, where c is going to be a vector. So we know that when t equals 0, when t equals 0, p is at position 36i. So what we can then type into that is 36i equals, now when you plug in t equals 0, you're going to get all of that equaling 0, all of that equaling 0, so that's just going to equal our c value. So there's no j component, just an I component. So therefore your final answer to part I is going to be t minus 2t squared. And given that this is the I component, I'll add 36 in there. But there's nothing for the j component, so I won't add anything to the j component. And there we are, that's taken care of the plus c. C is 36, so I've put 36 where the I components are. So there we are, that's our answer to part II. No, that's not our answer to part II. We've just found the expression for it. So now we need to find when t equals 4, the velocity is going to equal, let's do it on the calculator, 4 minus 2 times 4 squared, and then plus 36. And that's going to give us an answer of 8i plus 3 times 4 minus a third of 4 cubed, and that's going to give us an answer of minus 28 over 3j. That's going to be meters per second. So there we are, that's our answer to part I, finally. Find the value of t at the instant when p is moving in the direction perpendicular to I. Let's just imagine what that is going to be. If that's the I component, that's the j component. If it's moving perpendicular to the I vector, then it's moving in that direction. So what that's going to mean is that its I direction is going to be 0. So what that will mean, therefore, is the I component will equal 0. So therefore t minus 2t squared plus 36 will equal 0. Let's just rearrange it and maybe multiply by minus 1. So that will become a minus, this will become a minus as well. Minus 36 equals 0. So let's now substitute that into the polynomial solver on the calculator. So it's going to be 2 minus 1 minus 36. And that gives us an answer of t equals 4.5. And maybe a negative value that we're just going to discard. Yeah, because t is greater than or equal to 0. So there we are, that's the answer to part II. Moving on to part B now. At time t seconds, where t is greater than 0, a particle q moves so that its position vector r meters relative to a fixed origin O is given by this expression here. Find the value of t at the instant when the speed of q is 5 meters per second. Oh, a little tricky question, that one. So if we're given a position vector, such as t squared minus t lots of I plus 3tj, then to work out the speed, we first need velocity, and if we've got position and we need velocity, we differentiate. So we're going to differentiate here. So that's going to become 2t minus 1 on the I component and 3j on the j component. So we want the speed to be 5, so what we're now going to do is we're now going to do the Pythagoras calculation of 2t minus 1 squared add 3 squared equals 5, and now we're going to work out what t is equal to. So we'll square both sides, so it's going to be 2t minus 1 squared plus 9, because that's what 3 squared is equal to, equals 25. We'll now subtract 9 onto the other side, so that will now be 16. We can now square root both sides, so it will now be 2t minus 1 equals plus or minus 4. We'll add 1 to both sides. In fact, let's just separate it into two little equations now. 2t minus 1 equals 4. So we'll add 1 to both sides. That'll make it 5. So t equals 5 over 2. Or 2t minus 1 will equal minus 4, in which case if you add 1 to both sides, we're going to get minus 3, and divide by 2. So this is not a valid solution because it's a negative. Not valid solution. So therefore the answer to part B is going to be 2.5. So there we are, that's the answer for question 3, worth a total of 12 marks there for the third mechanics question. Let's now move on to the fourth mechanics question.